All right, let's go through a few more. So you have, the key to this is recognizing that you have this sum or difference of an angle. You can't, a lot of you are going to want to distribute a tangent. You can't do that. You have to first follow order of operations. You would have to first add x to 45 and then take the tangent of that. And since we don't know what x is, we have to use our formulas. And you look into your sum and difference formulas and you find your tangent of u plus v. And I've written that here in the green. And what we have to recognize is that we're going to replace all of the u's in that formula with x and all of the v's in that formula with 45. So when I rewrite that, I'm going to get tangent of x plus tangent of 45 over 1 minus tangent of x times tangent of 45. And again, I'm trying to show that this is equal to 1 plus tangent of x over 1 minus tangent of x. So the key to these problems is once you've used the formula, using your unit circle now, because tangent of 45 is an angle on my unit circle. So if I look at my unit circle, which you should have on your formula sheet, at 45 degrees, our ordered pair is radical 2 over 2, comma, radical 2 over 2. If I find the tangent of that, y divided by x, it's something divided by itself, that's just 1. So this expression just is 1. Okay, so what that looks like when we rewrite it is tangent of x plus 1 over 1 minus tangent of x times 1. Now, we can, clean that up just a little bit, but you should be able to see how that is the same as what's written on the other side with just one quick little additional rewrite. All right, next, let's talk about 5. So when I'm looking at, which side is going to be more complicated, I'd probably once again choose, this time choose the right side. But I want to make a little note to myself here. Again, I'm kind of reminding myself that on the left side, what I'm shooting for is sine of 2x is 2 times sine of x times cosine of x. Okay, so that's my goal on the left side. So I'm keeping that in mind as I'm working. So on the right side, you may want to, change cosine of 2x into one of the 3 possible formulas that you have. So there's actually 3 ways that you can change cosine of 2x. And those 3 ways are written over here on the right-hand side of your screen. So what I'm trying to remember that I'm doing is I'd like to get it down to the point where I just have one term on the right side, because I know on the left side I already have one term. So I'm kind of looking at, is there a way that I can get rid of this 1? So what I would need to do is I would need to change this into something that's subtracting a 1. So when I look through my 3 options, there's only one of the 3 where I subtract a 1, and that's this middle one. So that's my logic behind choosing that one first. Now, it may or may not work. So I'm going to give it a try and see where we end up. So instead of cosine of 2x, I'm going to do 2 cosine squared minus 1. Now, simplifying that a little bit, I get on the right side still sine of 2x, tangent of x, and then in the parentheses here, I'm just going to end up with 2 cosine squared because the 1 minus 1 is just going to be 0. And now I'm going to go ahead and change my tangent to sine and cosine, because I know, remembering that sine of 2x just includes sine and cosine, I'm going to change my tangent to reflect that. So using my quotient identity, we have sine of x over cosine of x. And then just to make things a little bit maybe easier to see, remember I'm going to use a fraction, I'm going to write 2 times cosine of x times cosine of x, because I do remember that cosine squared just means cosine times cosine. And then from there, I can easily find a giant 1. Now, the really nice thing about that is that what I'm left with is just 2 times, if I rearrange the terms here a little bit, sine of x times cosine of x. And then looking to my double angle formulas, I can see that I can rewrite that as just sine of 2x. All right, number 6. Once again, we have another double angle formula. So thinking about those 3 options, I might do kind of the same thing again. But what I have to watch is that here, I'm actually subtracting whatever this is. So when I think about my three possible cosine 2x formulas, I've got to take that minus sign into account. And I'm also going to pay attention to the fact that on the left side, I only see sine squareds. So it's going to make sense that I gravitate towards the three of those, the one of those three that just uses sine squared. So that would be this one here. Okay, so I'm going to replace this cosine of 2x with 1 minus 2 sine squared of x. So let's see what that looks like once I rewrite it. Now I need to watch, I'm going to subtract all of that. So I put it in parentheses. Okay, so now if I go through and simplify what's in the parentheses there, I get 1 minus 1 is 0, and then I get minus negative 2 sine squared. So that's actually going to be positive 2 sine squared. And then a simple multiplication here, 1/2 times 2 is going to give me sine squared. And then I've got it. All right, last one for this video is using another sum or difference formula. So we have this sum of two angles using sine. So our formula for that looks like this. Okay, now this is right off of your formula sheet, so you can look on it and see it. It's under sum and difference formulas. I recognize that u is going to become a and v is going to become pi. So I'm just going to rewrite the left side using my sum and difference formula. So I'll have sine of a times cosine of pi plus cosine of a times sine of pi. And what I need to show is that just is going to simplify to be negative sine of a. Again, we need to go to our unit circle because we've got a couple of values on there that we can definitely find. So on our unit circle, we're at the point pi, which has an ordered pair of negative 1, 0. So sine of a, we just leave as is, but cosine of pi, this entire thing is negative 1. Okay, so it's times negative 1. And then we have plus cosine a times sine of pi. Well, sine of pi is just 0, so this entire thing is just 0, so times 0. All right, now we just simplify. So sine of a times negative 1, well, that's negative sine of a. Cosine of a times 0, that's 0. And we've proven that it's true.